Good morning, students. Now we are discussing about the water tank design. Introduction about the water tank. A water tank is a container of storage water of many applications: drinking water or irrigation water, fire supply, farming, both are plants and livestock, chemical manufacturing and food preparation, as well as many other uses. The main purpose of the water tank is for storing some waters. The waters used in various purposes like this irrigations and so on, etc. Next one is classification of water tank. Water tank. Classification of water tank based on the location. Like the water tank is resting on the ground, and the water tank underground water tank. The water tank is below the ground. The next one is elevated water tank. Elevated water tank is the water tank is above the earth level. These three common methods are used in our India, like tank resting on the ground and tank under the ground and elevated water tanks. Next one is based on the shapes. The water tank is classified based on the shape, like circular tanks, then rectangular tanks, square tank and spherical tank, in-test tank. Most of the tanks like circular water tank is nowadays using on this in Tamil Nadu, like regional areas. Design components of the water tank. The main design components are followed by the water tank. One is the area of tank. First, find the area of the tank. Now the capacity is given in the problem. Now first you find the area. How to find the area? First, the volume of the water is given. So the volume into 10 to the power of 3. The volume is converted into capacity. Capacity in meter. So meter, then find the area. Then diameter of the tank. Pi r square is formula. Pi r square is equal to area. So area calculated. Next step is calculate the diameter of the tank. Then depth of the tank. The depth of the tank is mainly classified by the IRC code method is 2 to 4 meter. 2 to 4 meter is the basic length of the tank. And tank floor. This is like a basement of the tank. The basement of the tank is assumed 150 mm to 250 mm. And last one is the reinforcement detail of the tank. Okay. Next one is classification based on the water tank. What are the classification based on the joints? The circular tank with flexible joint, and another one is circular tank with fixed joints. The flexible joint means the height of the during the water in the tension, the tank is flexible. Like the diameter does not change, but the reaction, the tension due to the water tank is the flexible moment acting on the tank. Other one is fixed joint. Due to the water, the basement is fixed. No underground pressure, shear force like hook tension not acting on this joints. So now seeing the flexible joint. Okay, you now consider the flexible joint method water tanks. Design step. First, find the design constraints. Constraints means like height and depth. How to find depth and diameter of the tank. Find the dimensions of the tank. Dimension means depth of the tank, thickness of the base slab, diameter of the tank. Next one is the hoop tension of the tank. Hoop tension, how to find the hoop tension? T is equal to W into H into T. Now the W value is density of the water, H is the depth of the water in meter, and D is the diameter of the tank. P is the water pressure on the wall. Now calculating the flexible water tank. So the water pressure is calculated. So the previously find the dimension of the tank. The hoop tension is find the dimensions. Previously finding the dimensions put on the hoop tension. Then find thickness of the wall. Thickness of the wall is equal to the equivalent area of cross section and sigma Ct. T is the hoop tension. Already you know the T is hoop tension. Equivalent area. How to find equivalent area? Equivalent area formula is A plus M minus 1 into AST. Now A is 1000 time of T plus M minus 1 AST. Then the next step is distribution on hoop steel. Reduction in hoop steel. Reduction in hoop steel means the water tank due to the pressure below the top to medium level means the pressure is high. When compared to medium to top of the water tank, the hoop tension is reduced by the half percentage. So that reinforcement is distributed in the half of the tank is below half is more and the above half is less. And distribution of the reinforcement. Distribution of the reinforcement, how to find the distribution reinforcement is 0.3 percentage of Ag. Ag is the value of A into L. Okay. Then tank floor. This is the base slab. The base slab thickness is assumed. So this is the design steps. Now see, this is the question for a circular water tank. Design a circular water tank resting on the ground and having a flexible base at the bottom. The data are capacity 2 lakhs liters, concrete M20 grade and mild steel grade 1. The given concepts. The M20 grade of steel means CBC value is 7 Newton per mm square. Sigma Ct is 1.2 Newton mm square. M value is 13.3 and sigma St is 100 Newton per mm square as per the IS code values. Okay. First, dimension of the tank. The capacity of the tank is given. It is at 2 lakhs. The volume of the tank is, how to calculate the volume of the tank? The capacity is liters is converted into meter. So the capacity is 2 lakhs means it is converted into meter means 10 to the power minus 3. So the volume liter is converted into meter. So it is 200 meters square. This is very simple steps and assume the depth of the water is to be, previously I told that the depth of the water tank is 2 to 4 meter. So now assume the depth of the water is 2.5 meter. Then area of the tank. The area is divided by depth. How to find the area of tank? The area is already find the area 200 and the depth of the tank is 2.5. Now calculating the area, depth divided by height. So the area is 80 meters square. Then diameter of the tank. How to put diameter is pi d square by 4. The diameter of the tank, the diameter of the circular is pi r square. Now r means d by 2. So we put the pi d square divided by 4. So the tank diameter is equal to area. Previously we find the area 80 meters square. Now calculating the d. So d is pi d square by 4 equal to 80. D is 10.9 meter. Then dimension. Dimension, already we find the diameter, area. Now depth. Depth is water in the tank. The depth of the water in the tank is 2.5 meter. Then next we provide Freeboard means the water in the tank is fully whole. If placed in the water is not. The freeboard is must provided on the circular water tank. It is required for ventilation and so on. Okay. Then freeboard is 0.5 meter. We assume the value 0.5. Then total depth of the water tank is 3 meter. Water in the tank means 2.5 meter. The whole depth of the water tank means it is 3 meter. Okay. Then hoop tension and steel. Already know the formula for hoop tension. Hoop tension means T is equal to W into H into D. Now W is, you know the value of the density of water. What is the value of density of water? 10 is the density of water. So the unit is 10 kilonewton per meter cube. What is the height of the tank? We already find the overall tank depth is 3 meter. What is the diameter? Diameter is already you find. D is equal to 10.1 meter. So we substitute the value and then multiply. The hoop tension is 151.5. So we round off the value 152 kilonewton. Then steel per meter height of the wall. It is considered as a slab. So continuous slab. For steel, AST, area of steel is considered for 1 meter. Then AST is equal to T divided by the hoop tension divided by sigma ST. Sigma ST means the tensile stress. So the hoop tension divided by sigma ST is equal to, we know the value of T, 152 into, it is converted in mm. We already find the value is kilonewton, 15 to kilonewton. The kilonewton is converted into newton. It is multiplied by 10 to the power of 3. So the T value is divided by ST. Sigma ST is 100. So substitute the value and multiply the AST. AST is 1520 mm square. Providing 16 mm of die-off bar. That means it is a circular water tank. So we need to provide 16 mm die-off bar. Always you use small die-off rod means the spacing is very less value. So you provide large number, 16 or 20, whatever you like, you decide it, your wish. So first, now I am providing 16 mm die-off bar. Die-off bar means the area. How to find the small AST value? The area of reinforcement rod area. How to find? Pi r square divided by 4. This is pi r square divided by 4. So we find the pi r square value. Then spacing. Already we find the capital AST. This is means area of steel in the concrete. So this one, small AST divided by capital AST. Now my answer is spacing is equal to 132.236. This round the value is 130 mm. So we need provide to 16 mm die-off bar at 130 mm center to center distance. Okay. Then we find the thickness of the wall. What is the thickness? Now find the diameter, height and overall distribution of the reinforcement. Then thickness. What is the thickness? This is around the circular wall. The wall thickness, it will be considered as a mm. Okay. Then tension equal to equivalent area of cross section into permissible stresses in the concrete. Okay, this is the formula for thickness. T is equal to, already you know the hoop tension. T equal to 1000 T plus m minus 1 AST into sigma CT. Now the value is T is, we know the value. The hoop tension is 152 into 10 to the power 3. and 1000 T is the formula. M is the modular ratio. We know the modular ratio 13.33, and AST value is we previously found the AST, area of reinforcement, 1520. Then sigma CT. Sigma CT value is 1.2. We know the sigma CT. Multiply the answer and find the thickness of the wall. The water tank wall thickness is 107.92 mm. It is taken by 110 mm. Okay. Then reduction in hoop tension steel. What is the reduction in hoop tension? I previously explained the water tank means the water due to the pressure acting bottom to half of the tank is more, then bottom to half of the tank is more, and the half of the tank to top is less, it partially less. So the pressure due to the water on the wall goes to reducing towards the top. The pressure is to reduce towards the top. Hence the steel can be reduced. So the area of steel is reduced, keeping the thickness of the wall. Now steel at. Now the tank height is 3 meter. So the half of the tank means 1.5 meter. Below the top of wall. So 1.5 to below top of the wall. Find the AST. Okay. Now the hoop tension is W into H into D divided by 2. Now where W is the density of water. We know the value 10 Newton per mm square. And H means the below the top of the wall. So below the top means overall height is 3 meter. It is divided by 2. So 1.5 meter. Now we put the value, height means 1.5 meter. Depth already, diameter already we know the diameter. Diameter of the tank is 10.1. Is divided by 2. Then multiplying the density, height, diameter, we divided by 2. We find the hoop tension. Hoop tension is 75.75 kilonewton. We round off the value 76 kilonewton. Okay. Then find the area of reinforcement. Already you use this formula. Area of reinforcement equal to tension divided by sigma st. Previous step we find the hoop tension. 76 in 10 to the power t. Sigma st value is already we know the value divided by 100. Is equal to sigma st is equal to 760 mm square. Already previously you providing 16 mm steel bar. So now only using the 60 mm dia of bar. Area now calculating the area of 1 bar is equal to 201 mm square. Okay. Spacing is equal to small ast. Small ast means pi d square divided by 4. Now pi d value is 16 square divided by 4. This is the value of area of 1 bar, 201 mm square. So spacing is equal to small ast divided by capital AST. Capital AST value is you know. So substitute the value and put the spacing. Find the spacing is 276.3 meter. So round off the spacing. So we provide 275 mm. Then vertical steel. Now we find the circular steel area. Now we find the main. Previously where we find the main reinforcement of the circular tank. Now finding the vertical steel. Vertical steel means distribution of steel reinforcement. We providing is a mesh type of reinforcement, like one is horizontal, one is vertical. So these methods are provided, but we already previously finding the main reinforcement. So horizontal reinforcement details are already found. Now vertical reinforcement of the steel. This is distribution reinforcement. Okay, distribution reinforcement formula is 0.3% of Ag. What is 0.3% of Ag? Ag means now Ag, area of tank. Ag means the thickness of the tank value is put the Ag. 0.3 divided by 100 into 1000. It is considered as a meter per meter. So 1000 into thickness of the tank. Thickness of the tank value is what? How 110. You previously find the thickness of the bed. You substitute the thickness of the tank, then get the AST value. Providing, this is a distribution rod, so we need provide the diameter is compared to less. You provide 8 meter diameter, the spacing of the bar is, the diameter is small, means the spacing is very less. When increasing the diameter, the spacing also increases. So we provided a 10 meter bars. Area of one bar is 878.5 mm square. How to find the area? Pi d square by 4. Okay. Then spacing. How to find the spacing? The small AST divided by capital AST. Capital AST means 0.3% of Ag. We already find the value and get the spacing. Spacing is 337.87 mm. So we it's round the value 235 mm. So the spacing of a vertical bar is, so we provide 10 mm diaph bar at 235 mm center to center. Okay. Next one is, we already previously find the diameter, height and depth and horizontal reinforcement, vertical reinforcement, then tank floor, the water tank floor. Last one is floor. How to find the floor thickness? Providing the base of the tank is 15 mm. We assume that. Providing base thickness of the tank is 150 mm. The AST, the area of steel, now finding the AST of the base tank. AST is equal to 0.3% of Ag. Area of steel 0.3% of Ag. When previously we found the counterfort meant 0.1% of BD. So it is differ from water tank and retaining wall and so on. Okay. AST is equal to 0.3% of 100 for per meter depth means into 1000 into the thickness of the base tank is 150. We substitute, we know the all values and substitute the value, we get the answer for 450 mm square. Okay. Whenever you find the area of reinforcement, the next step is spacing. You find the AST means you must find another step is spacing. Then the spacing of 10 mm diaph bars, it provide 10 mm. So spacing is equal to small AST divided by capital AST. We know the area of steel in main. So the value is 450. Substituting the 450 value. So spacing is 174.4 mm. It is round the value 170 mm. So we need to provide the spacing of the base slab is provide 10 mm diaph bar at 170 mm center to center. Okay. Then now this design is over. Summary of the design. First you finding diameter of the tank, then depth of the tank, then tank wall thickness And steel, area of steel 3 meter, the whole thick height is 3 meter circular water tank. The 1.5 meter below the top, 1.5 meter below the top means we provide 16 mm dia of bar at the center of 130 mm center to center distance. 1.5 meter to 0 meter below the top. Below the top means 16 mm dia of bar is 275 mm center to center. And we last find the vertical steel. Vertical steel is 10 mm. We provide 10 mm diameter. So vertical steel is 10 mm diameter at the center of 235 mm. Okay. Now first I explain the top of the bar means the diameter is space, like space 275 mm, and the below ground level means 130 mm. The spacing is less. More than top means the spacing is high. Okay. Then the tank floor. Tank floor, the thickness of the tank floor is 150 mm. We will assume the steel is 10 mm diameter of the steel is provided at the center of 170 mm. Okay. This is the summary of the design. We easily find the value of diameter, depth, thickness and area of reinforcement in a circular water tank. The water tank is flexible base. Okay. This is the reinforcement detail of the flexible base water tank. This is the base slab. Base slab value is 150 mm. We know the value. Then thickness of the wall. What is the thickness of the wall? This is thickness of the circular water tank. This is 110 mm. This is the vertical reinforcement is 10 mm dia of bar at 235 mm centers to center. Now the steel in main reinforcement like a horizontal bar. Horizontal bar diameter is taken as a 16 mm. So the shear stress, the tension is acting more on the below the water tank is more. So we provide 16 mm dia of bar at the center to center distance is 130 mm. Compared to the top, above the water, above the water tank is less. So we provide 16 mm dia of bar, but the center to center spacing is more, like 175 mm. Okay. This is a flexible joint. And we need to provide freeboard. The water is full height means 3 meter is not stored in the water. We must provide 0.5 mm for freeboard. This is there. Then last one is the base slab. Base slab is we have previously calculated the base slab reinforcement. This is the base slab 10 mm. We use 10 mm dia of bar at 170 center to center. Okay. This is the reinforcement detail of the water tank. Okay. Now revise the check. First, design concept. Design concept means we take the value from the questions. Next one is find the diameter of the tank. Diameter means we find the value of D and H and area of the tank. Next one is dimension. Overall depth of the water is free. We assume the value of the freeboard is 0.5 meter and overall depth is 3 meter. And next one is hoop tension on the steel. In water tank, the water acting on the hoop tension. This is the formula for T is equal to W into H into D divided by 2. Then tension value. Tension means AST minimum, area of main reinforcement, and the spacing is found.
Next one is thickness of the wall. Thickness of the wall means the tension is equivalent area of the cross section into permissible tensile stress in concrete. Also find the tension value. No, this is find the thickness of the wall. Okay. Next one is reduction in hoop tension steel. The medium to above the water, top of the water tank is the reinforcement is spacing is very high. Once the pressure distribution is towards reduced, so we provide large spacing with bar. Okay, so we need to calculate the tension, AST and spacing. Then vertical reinforcement. Vertical reinforcement means we find the area of reinforcement in the bottom, we find the area of reinforcement in the top. Now we distribute the distribution reinforcement is vertical reinforcement. This AST is equal to 0.3% of AST. Now calculating the AST and the spacing of the bar. Next, water tank. Tank floor. Tank floor means the basement of the tank. We assume thickness is 150 and we calculating the AST and spacing and distribution. Okay, this is a design summary. Easily we find the design the water tank. It is a very easy method. Thank you.